Hello, how is everyone doing? Today's lesson would be on solving quadratic equations using the quadratic formula with irrational solutions that can be simplified with a factor tree. All right, so at this point, you should be expected to understand the quadratic formula well, and you would also know how to simplify radicals. If you don't, you could also follow it in here. So we're kind of merging radical simplifying with the quadratic formula. All right, so we're going to do two examples. The first example will be negative 2x squared minus 12x plus 17 equals negative 4x squared. All right, so first you have to do is set equation to 0. So we'll add the 4x squared, get rid of that, put it under the like term. Then you get 2x squared minus 12x plus 17 equals 0. I like to label A, B, C, and then you set up your quadratic formula. So opposite B would be 12 plus or minus b squared, make sure you use parentheses, minus 4 times a is 2, and c is 17, all divided by 2a, which would give you 4. All right, so you can either do some mental math. Negative 12 squared is 144, minus 8 and 17 would, I believe, be 80, and 56 is 136. Or if you don't trust yourself, you could simply use a calculator. So negative 12. So we're basically finding the discriminant, which is the inside portion of the quadratic formula, just to simplify the problem further. So that was 144, take away, I think I said 132, which is 8. All right, so watch how nicely this works. Now keep in mind, this solution is irrational because 8 is not a perfect square, okay? So we're going to have to do the factor tree method on square root of 8. So I'll do that on the side. So square root of 8 breaks down to 4 and 2. You have a pair of 2's, so these are two friends. So circle that. And then the leftover or lonely friend stays inside the radical. So your answer would be 2 radical 2. All right. So we replace square root of 8 with 2 radical 2. So x equals 12 plus or minus 2 radical 2 over 4. All right. Now the last step's pretty simple. You got to take the first term, which is the 12, and the second term is the 2 radical 2. 12 divided by 4 would give you 3, plus or minus 2 over 4. Think about it. If you ate 2 slices of pizza and there was 4 total, you ate 1/2 of the slices that were on the table. So you could put the radical up top like that, or you could write the answer with the radical on the side. Either or is acceptable. All right, so there's 2 solutions. Well, I gave you 2 ways to write the solutions, but one answer would be 3 plus 1 radical 2 over 2, or 3 minus radical 2 over 2. And the 1 here is optional. Okay, so we'll look at one more example. This would be x squared plus 10x plus 8. So this one's already equal to 0. A, B, and C are there. So you set up the formula opposite B plus or minus the square root of B squared is 100. So I'm just skipping some steps. Minus 4 times 1 times C would be 8. Again, there's a 1 in front of the x squared over 2a, which is basically just 2. So 4 times 1 is 4. Multiply that by 8 is 32. You could use a calculator or just mental math. 100 minus 32 would be 68. All right. So then we're going to do a factor tree with this. So square root of 68 breaks down. You can always divide it by 2, 34. 34 is also even. You could divide by 2, you get 17. 17 is a prime number, so are 2 and 2. This is a pair. Maybe it's Mario and Luigi. So the pair goes outside. The lonely number 17 stays inside. So that's what square root of 68 equals, 2 square root 17. So then we have one final step. We replace the 68 with 2 radical 17. Then we simplify. All right. So negative 10 divided by 2 is easy. That's negative 5. And then 2 divided by 2 would be 1. So that's your answer. Again, the 1 is optional, but your answer would be negative 5 plus or minus square root of 17. Okay, so once again, that was quadratic formula with irrational solutions, meaning we had to simplify the square root with a factor tree. Thank you for listening. Hope you guys learned a lot.